All right, here we go. Extension 5.1 in relations and functions. So, a relation will pair inputs with outputs. A relation that pairs each input with exactly one output is a function. You can do a vertical line test when it is on a graph. Basically, I can't show you on this video, but imagine that dotted line is like your pencil going across the paper. And you can see that it is only touching one point at a time. So the vertical line test says a graph represents a function when no vertical line passes through more than one point on the graph, right? So on the left, it is a function. On the right, not a function. There is a point here and pretty much everywhere past this very end. So let's take a look at what this looks like. So we're going to determine whether each relation is a function. And then let's see here. Okay, and how you'll do that is look at all the inputs, -2, -1, 0, 1, 2, also known as the domain. Each input has exactly one output. Also, they are distinctly different, right? So they are distinctly different. No two inputs are duplicated. So it is a function. Now look at part B. You have inputs of -2, -1, 0, 0, 1, and 2. These two zeros, they're duplicated inputs, but they are going to different outputs, okay? So that is showing us right here, right, that 0 has two outputs, 5 and 6. It's not a function because think about like writing a rule in which you put in a 0, sometimes get a 5, put in a 0, sometimes get a 6. Mathematically, that doesn't make sense, following all of the orders of operation, everything else. So this is why it becomes not a function. All right, looking at this diagram, we have an input and output. So -9 pairs with 0, -2 with 5, 5 with 10, and 12 with 10. Every input has exactly one output. Okay, it's okay that these two inputs go to the same output. Think about a horizontal line. Each input would go to the exact same number, and you have a horizontal line that passes the vertical line test. So the relation is a function. What you can't have happen is also having this 5 paired with this 5 or 0 or something else. So you can have two arrows heads pointing to an output, but you cannot have two lines branching off if you see it in a table like this, right? So make sure, and unless they have the numbers repeated, always pay attention that they didn't repeat the numbers, because I've seen them do that before as well, and I thought that it was a function, but then one of the numbers was repeated, so it only looked like single arrows. So be very careful when you're doing that. So mainly look at that the numbers are repeated. Let's see, I am on pen, so I want to get to the mouse. Let's get to a firework mouse. Okay, let's be fun. So here, oh, I guess I forgot to clear the circle. Okay, so here we're going to determine whether the relation is a function. We're going to look first at the ordered pairs. So -5, 0, 5, 5. So here we see a 5 paired with 0 and a 5 paired with a 10. So 5 is paired with two outputs, 0 and 10. Therefore, not a function. To be a function, it is paired with exactly 1. Inputs distinctly different, each paired, so this is representative of a function because each input and this is how you would explain it. Each input is paired with exactly one output. Okay, here we have 1/2 going to -1/4, to 0, and to 1/4 because it is going to different outputs. So 1/2 paired with 3 different outputs, not a function. Okay? All right. Going to clear. All right, now we're going to determine if these statements are true or false and explain our reasoning. So looking at the first one, every function is a relation. Well, by definition, a relation is just the ordered pairs, right? The inputs paired with the outputs, pairs of inputs and outputs. So yes, and to be a function is when each input is paired with exactly one output. So yes, this is true and it's by definition. I got a pen, yeah. So number 4 is true and it's by definition of what a relation is. Okay. Every relation is a function. Well, that's not necessarily. That's going to be false. And it's true, only if each input paired with one output, then it could be true. Okay, when you switch the inputs and outputs of any function, the resulting relation is a function. Now, this is going to be false, right? What if you have a function where 2 inputs have the same output? We could have that. So this is false because for a function, where 2 inputs have the same output, when switched, the new input has 2 different outputs. I know it's a lot of words with a lot of meaning. Okay, so the reasoning here. So you record the number X of runs scored by the winning team and the number Y runs scored by the losing team, okay, in a team's season. Does the relation necessarily represent a function? Do you think that if you're just keeping track of scores for Team X and Team Y for the whole season, is it going to be a function? I mean, no, not necessarily. And the reason it's no is because there could be a time when a team could score the same number of runs in a season while their opponent scored a different number of runs. So no. Right? So say your team scored 3 runs and the other team scored 5 runs in one game. But then say the next game you also scored 3 runs, but now they scored 2 runs, right? So you lost one, you won one, but now you have 2 threes paired with 2 different outcomes. So we couldn't call that a function. We couldn't write a rule for that. There's too many variables here. This isn't what functions are. Okay. So because a team could score the same number of runs in a season and their opponent could score different number. And then when you reverse it, or when you look at it, it wouldn't necessarily represent a function. So I know that's a lot of words. If you want to take a minute to pause the video and write that down, so you can have it to look back on or ask questions about later. I'm going to clear the screen. All right, now let's do the vertical line test. Determine whether a function or the graph represents a function. So again, you kind of draw some vertical lines here. I'll change the color here. At any point, is the line touching 2 or more? So yes, it's a function. And again, each input paired with one output, and we know that because the line isn't touching more than one point. Okay, when you do the same here, anytime I draw this line, and this line is just supposed to be like representative of like your pencil going through. Notice that it's not really touching two things. So this is also, yes, function, right? Each input paired with one output. All right, try this one. Alert, alert. Hey, it's touching 2 points. Oh no. Houston, we have a problem. Okay, so it failed the vertical line test. Not a function. Right? Because inputs are paired with more than one output. All right. Wisdom comes not from age, but from education and learning. And that is all. I might put a question for you to answer. And then if you have any other questions, please let me know. Since this was the extension, there is no vocab to respond to. All right.